Insecure cryptographic storage is actually a pretty broad topic because there are so many different ways that we can implement cryptographic storage of sensitive data. Now, IWASP does cover this in their top 10 web application security risks, and in fact it was risk number 6, sensitive data exposure. And one of the things that they talk about in sensitive data exposure is improper use of cryptographic paradigms. And that's exactly what I want to show you here. So I'm going to show you one of the most common misconceptions about how passwords should be stored in systems. And that's how storing passwords as salted hashes is often done in a weak fashion. Now, in order to explain that, I need to begin by explaining what a salted hash is. So let's run through the process here. And I want to talk first of all about registration. Now let's imagine we have a user who wants to register in a system. Now, as part of the registration process, the user provides a plain text password. That's submitted to the server, along with other data in the registration process, of course, things like a username and other typical registration type data. That doesn't matter too much for this example. The point is, they register and provide a plain text password. Now, when we talk about a salted hash, what the application does is it generates a salt, which is a set of random bytes. It then takes both the salt and the password that the user has provided, and it hashes them. Now, both those attributes, the salt itself and the hash of the salt and the password, get stored in the database. Now, why do we do this? Well, here's the reason. If you have multiple users create the same password, because the salt is always unique, you'll always end up with the unique salted hash. The reason that's beneficial is because it makes the cracking process of those hashes enormously slower. So for example, if you had 100 users use the password, but with a 0 instead of an O, if you were just creating a direct hash of that password, every output would be the same. You'd crack it once and every user's password would be compromised. However, if you generate a salt, then 100 users with the same password means 100 different salted hashes. Now, not only does it mean that the salted hash is different for users of this system with the same password, but it also means that any other users of any other systems using the same password always have a different salted hash. That makes the pre-computing of hashes useless. So we used to see a lot of rainbow tables, which were basically just large tables of pre-computed hashes. So someone would go through and pre-compute all of, say, the MD5 algorithm hashes for the top 100,000 passwords. And then you'd compare that to the passwords breached from a system that were also stored with MD5, and whenever there was a match of the hash, the rainbow table would also provide a map to the plain text equivalent. So this is why we salt. Now let's talk through the login process as well, just to make it clear how this works later on when the user comes back to the system. So we'll start with our user again. The user logs in by providing the username and the plain text password. So this is what we all do when we log into a system. It's just those two attributes. That goes to the web application. Now the web application takes the username and sends it off to the database. And effectively what it's doing is just saying, hey, get me the user who owns this username. The password isn't involved yet, it's just checking by username. Now the database responds, and if it finds a user for that username, it brings back the salt and the salted hash of the password. So this is what we just saved earlier on in the registration process. If the database doesn't find the username, it can just simply say, hey, your login credentials were incorrect. But assuming it does find that username, it comes back with the salt and the salted hash of the password. Now the web application can then hash the plain text password that was provided by the user with their salt that was just retrieved from the database and compare it to the salted hash that was stored in the database. Now if they match, the web app can respond and say, hey, now you're logged in. If they don't match, the web app can respond and say that the credentials were incorrect. So this is how the cycle works. It always depends on recreating the stored hash by looking at the plain text password the user provides and the salt that is stored for them in the database. Now, people believed this was a good mechanism, and parts of it are good, but parts of it are also very weak. And the weakness comes because of the fact that if the database gets leaked and the salts and the salted hashes are exposed, then you can effectively go through and recreate this logon process using cracking software. When we talk about cracking password hashes, we're not talking about breaking the algorithm. We're simply talking about reproducing this process. So that's what we're going to do now. And I want to begin by showing you what a collection of salted hashes stored in the database actually looks like.